Check engine light on? Take the guesswork out of your check engine light with O'Reilly Veriscan. It's free. Ask for O'Reilly Veriscan today.
O'Reilly Auto Parts.
Welcome to Astronomy Daily. I'm excited to bring you another packed episode of space and astronomy news. Today we have some great stories to share, starting with a groundbreaking discovery about Jupiter's volcanic moon Io that's challenging everything we thought we knew about its interior structure. We'll also look at an incredibly busy week ahead in spaceflight, with multiple launches scheduled from SpaceX, including their next crew mission to the International Space Station. Rocket Lab, Firefly, and several international launch providers are also preparing for liftoffs in the coming days. In our coverage of cosmic mysteries, we'll explore fascinating new research about dark matter at the heart of our Milky Way galaxy that could revolutionize our understanding of this enigmatic substance. We'll also check in on NASA's Artemis program as it takes another step toward returning humans to the moon. And we'll round things out with an interesting look at some growing pains at SpaceX, where recent challenges might suggest the company is approaching its operational limits, even as it maintains an unprecedented launch cadence. Let's dive into these stories and explore the latest developments in space exploration and astronomy. In a fascinating development, NASA's Juno spacecraft has revealed surprising new insights about Jupiter's most volcanic moon, Io. Data from recent flybys suggests that, contrary to long-held beliefs, Io doesn't have a shallow global magma ocean beneath its surface. Instead, the moon's mantle appears to be mostly solid, forcing scientists to rethink their understanding of how this incredibly active world functions. Io experiences intense geological activity due to the powerful gravitational forces from Jupiter. As the moon follows its elliptical orbit, Jupiter's massive gravitational pull stretches and compresses it, generating tremendous internal heat. This process, known as tidal heating, is responsible for Io's status as the most volcanically active body in our solar system. For years, scientists theorized that this constant gravitational kneading could create and maintain a global underground ocean of molten rock. However, when researchers analyzed measurements of Io's tidal deformation, how much its surface flexes under Jupiter's gravitational stress, the data told a different story. The team, led by Ryan Park, found that the way Io responds to these forces isn't consistent with what we'd expect if a shallow magma ocean were present. The findings don't rule out the possibility of some deeper magma chambers or isolated pockets of molten rock, but they do suggest that Io's internal structure is more complex than previously thought. This discovery has broader implications for our understanding of how tidal forces affect worlds throughout the solar system, including other moons like Europa and Enceladus that experience similar gravitational interactions with their parent planets. This revelation from Juno adds another layer to our evolving picture of Io, showing us that even after decades of observation, this fascinating moon still has secrets to reveal. The findings challenge us to develop new models to explain how Io maintains its extraordinary volcanic activity without a global magma ocean, opening up exciting new questions for planetary scientists to explore. Let's turn our attention now to this week's launch roster. Get ready for an incredibly busy week in spaceflight with multiple launches scheduled across the globe. SpaceX leads the packed schedule with several missions, including the highly anticipated Crew 10 flight to the International Space Station. The Crew 10 mission will launch from Kennedy Space Center's Launch Complex 39A, carrying NASA astronauts Anne McClain and Nicole Ayers, JAXA astronaut Takuya Onishi, and Roscosmos cosmonaut Kirill Peskov to the space station. They'll be flying aboard the Crew Dragon Endurance, making its fourth trip to space. This particular Dragon previously supported the Crew 3, Crew 5, and Crew 7 missions. SpaceX also has multiple Starlink launches on the manifest, including 2 missions from Florida's Space Coast. These launches will continue expanding the company's satellite internet constellation, with some of the satellites featuring new direct-to-cell capabilities that could eventually enable mobile phone connectivity from space. In California, SpaceX had planned to launch 2 NASA science missions, SphereX and Punch. SphereX will study the early universe and search for the building blocks of life within our galaxy, while Punch will investigate solar winds and their effects on the heliosphere using a network of 4 small satellites. However, I believe this launch has just been delayed and will be rescheduled. Rocket Lab is preparing for their 3rd mission of 2025 from New Zealand, appropriately titled The Lightning God Reigns. They'll be launching a synthetic aperture radar satellite for IQPS, marking the first of 8 planned launches to help build out their Earth observation constellation. Firefly Aerospace is set to launch their Alpha rocket from Vandenberg Space Force Base, carrying Lockheed Martin's new LM-400 satellite bus on a demonstration mission. This will be Alpha's first flight of the year and 6th overall. On the international front, China's Changzheng-8 rocket will make history with the first launch from a new commercial pad at Wenchang, while Russia prepares an Angara rocket launch from Plesetsk, carrying an unspecified military payload. This intense launch cadence reflects the growing commercialization of space access and the increasing diversity of launch providers worldwide. It's a testament to how far we've come from the days when orbital launches were rare events, sometimes happening only a few times per year. Next up. A fascinating discovery at the heart of our Milky Way galaxy could provide new insights into one of the universe's most perplexing mysteries, dark matter. Scientists have identified strange events in the galaxy's central molecular zone that might be evidence of a previously unknown form of dark matter, one that's lighter than existing theoretical candidates. This new dark matter suspect has a unique characteristic: it's self-annihilating. When two particles meet, they destroy each other, creating pairs of electrons and their antimatter counterparts, positrons. This process releases energy that strips electrons from neutral atoms in the dense gas at our galaxy's center, a process known as ionization. The theory elegantly explains why there's so much ionized gas in the central molecular zone. While this annihilation process might be rare, it would naturally occur more frequently in galactic centers where dark matter is thought to concentrate. Traditional explanations involving cosmic rays don't fully account for the observed levels of ionization, and importantly, don't match other expected signatures like gamma-ray emissions. What makes this discovery particularly intriguing is that it suggests we might have been looking for dark matter in the wrong way. Instead of focusing solely on gravitational effects, we might be able to detect dark matter through its subtle influence on cosmic chemistry. It's like finding footprints in the sand. While we can't see the person who made them, we can study their impact on the environment. The research team's calculations show that this lighter form of dark matter fits perfectly within existing constraints, without contradicting other observations from gamma-ray telescopes or the cosmic microwave background. This is remarkably rare in dark matter research, where proposed explanations often conflict with existing data. Looking ahead, NASA's upcoming COSI Gamma-Ray Telescope, scheduled for launch in 2027, could provide crucial evidence to support or challenge this theory. If confirmed, this discovery would open an entirely new avenue for studying dark matter, fundamentally changing our approach to understanding the mysterious substance that makes up 85% of the matter in our universe. This represents a potential paradigm shift in dark matter research, suggesting that the key to understanding this elusive substance might lie not in its gravitational effects, but in its subtle chemical influence on the very fabric of our galaxy. In an important development for NASA's Artemis program, the upper stage for the Artemis II SLS rocket arrived at Kennedy Space Center on March 4th. This crucial component, known as the Interim Cryogenic Propulsion Stage, was delivered by Boeing and United Launch Alliance to the Multi-Payload Processing Facility. The delivery marks another significant step forward in NASA's mission to return humans to the moon. This 4-story propulsion system, powered by an RL-10 engine, will play a vital role in the mission profile. After launch, it will provide the Orion spacecraft with the necessary thrust to complete 2 orbits around Earth before embarking on its journey to the moon. Technicians at the processing facility will now begin the meticulous work of preparing the upper stage for integration with the rest of the SLS rocket. Their first task will be fueling the stage with hydrazine for its reaction control system. Once this is complete, the component will be transported to the vehicle assembly building, where it will be integrated with other elements of the rocket atop Mobile Launcher 1. The assembly process is already well underway, with the solid rocket booster segments already in place. The core stage will soon be integrated, followed by the launch vehicle stage adapter. The upper stage will then be carefully mated to this adapter, bringing us one step closer to launch. This milestone delivery demonstrates the steady progress being made on the Artemis II mission, which will be the first crewed mission of NASA's New Moon exploration program. Each component that arrives at Kennedy Space Center brings us closer to the historic moment when humans will once again venture beyond low Earth orbit and return to lunar space. SpaceX has been experiencing an uncharacteristically challenging start to 2025, facing a series of technical issues despite maintaining their position as the world's leading launch provider. While the company continues to demonstrate remarkable launch frequency, recent events suggest they may be approaching their operational limits. Several notable incidents have raised concerns. The SpaceX mission, originally scheduled for late February, has faced nearly 2 weeks of delays due to integration problems. Though, to be fair, the latest delay is due to weather, and even SpaceX can't control that. More seriously, there have been issues with the Falcon 9's first stage, including a recent launch where a fuel leak led to a post-landing fire that caused the booster to topple on the drone ship. This marks the second landing failure in just 6 months, following a similar engine compartment fire last August. The company has also encountered recurring problems with the Falcon 9's upper stage. In early February, a failed deorbit burn resulted in propellant tanks crashing into western Poland. While fortunately no one was harmed, this marked the third upper stage issue in half a year. Adding to these challenges, SpaceX's Starship vehicle has experienced 2 consecutive test flight failures, with both attempts ending in spectacular explosions over the Bahamas. However, it's important to put these setbacks in perspective. SpaceX maintains an impressive success rate in delivering payloads to orbit, with only 1 operational payload loss in nearly a decade. Their launch cadence remains unmatched globally, with 27 missions already completed this year, outpacing the combined total of all other launch providers worldwide. These recent challenges may be indicating the natural consequences of SpaceX's aggressive pace and ambitious goals. The company is simultaneously managing the world's busiest launch schedule, operating a massive satellite constellation, conducting human spaceflight missions, and developing the largest rocket ever built. This combination of high operational tempo and continuing innovation appears to be testing the limits of what's currently possible in commercial spaceflight. These growing pains come at a crucial time, as SpaceX remains the Western world's sole provider of human access to orbit and the primary launch vehicle for NASA's science missions. While these recent issues haven't compromised their dominant position in the industry, they serve as a reminder that even the most successful space company must carefully balance speed and reliability. And that's all for today's episode of Astronomy Daily. We've covered some fascinating developments, from surprising discoveries about Io's interior to the intense launch schedule ahead, and SpaceX's current challenges as they push the boundaries of commercial spaceflight. If you'd like to stay up to date with all the latest space and astronomy news, head over to our website at astronomydaily.io. There you'll find our constantly updating newsfeed and can listen to all our previous episodes. We're also expanding our social media presence. You can now find us across all major platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, TikTok, and as of today, we're excited to announce we've joined Instagram as well. Being our first day, we could do with some follower love. It's awfully lonely there at the moment. I'm Anna, and thank you for joining me today on Astronomy Daily. Keep looking up, and I'll see you tomorrow. Bye.